Okay, this will be video one. I'll try and do a video for each of these slides. I'll just go into the main points. Yeah, so starting off, we're looking at volume. So we're looking at the volume of various different shapes. Now, fundamentally, what this first bit is talking about is saying that you're looking for an area, and you're going to multiply that area by a length. Okay, that's at the heart of what we're doing with volume. Now, here we've actually got two types of shape, okay, a special type. The special type is here, that's the cube, okay? So the cube special, cube with my amazing handwriting. I'm actually, I'm going to rewrite that because that's upsetting me so much with the terrible handwriting. Let's see, I'll use a slightly thicker pen as well. Okay, there we go. So there's the cube, okay? The cube's special because all the lengths are the same side, okay? So this is the same as this, is the same as this, etc. Okay, they're all the same. In fact, that's slightly too thick. I'll go back down one. Okay. So to work out the volume of the cube, you'd be doing the area times the length, but because they're all the same, you're effectively doing the length cubed. Okay. So you work out what one length is, and you times it by another length. And by doing that, by multiplying those two lengths, you would work out this area. Okay, so it'd be length and length. By multiplying that by another length, okay, you're actually dragging this shape. You're dragging this square, okay, into the other plane, okay, by timesing it by its length again. Okay, you're dragging it that way. Okay, so by doing that, you actually calculate the volume. Okay, so length times length gives us this area, times another length gives us the volume. So that's our special case of the cube. This would be a cuboid or a square prism. Okay, so it's the same except instead of all the sides being the same, this square is dragged a length. Okay, not the same as these lengths. Okay, so that could be 5 and 5 and 10. Okay, but again, a shape dragged. This would be your pentagonal prism. So again, square prism, pentagonal, triangular prism. A prism is just three-dimensional shape where we take an area and we drag it. Okay, in this case, we're taking a triangle, we're dragging it. Here we're taking a pentagon and dragging it, and then a square. Okay, cylinders are the other one. It's similar to a prism in that we've got these two shapes at both ends that we've dragged. However, for the prism, it's all flat surfaces. Okay, with the cylinder, it's curved. Okay, so the base of the cylinder is a circle. Okay, so for these ones, we could have any shapes. For the cylinder, it's going to be a circle. Okay. So the first thing to think about then is just jog your memory. Well, what's the area of these shapes? Well, the area of a triangle, that's going to be a half times base times height. Okay. And for the area of a pentagon, we actually don't need to cover that in the syllabus. You would probably get that area if it was such a shape, or they would split it into triangles or something for you. The other shape you'll need to know will be your circle, which is pi r squared. Okay, so that's your areas. Okay, you would then just take those areas and multiply them by the height. Okay, to get the volume of the cylinder. And for the triangle, you'd multiply it by I'll call it length actually. Okay, call that length to work out your volume. Okay, so just think about that. It's area times a length. Okay, cube's the special case. A prism has got flat surfaces, whereas the cylinder's got the rounded ones. Okay, simple. Some examples here we went over. So let's work out the area of this cube. That'll be 5 times 5 times 5. That's 125. Don't forget your units. For that one would be millimeters cubed. Okay. This shape here, what would be our area? Well, we could use two areas. We could use 7 times 3 to give us 21. Okay, so it's be 21 in here. Then we could times that by 25. Or we could do the area of this shape in here, which would be 25 times 3, which would be 75. Pardon me. And then times that by this length, okay, because we're going along this way. Okay, simple. These ones a bit more complicated. Area times the length of 5, 20 times 5, dead straightforward really, isn't it? So you just do 20 times 5 for that one, so that's going to be 120 millimeters cubed, simple. The triangles that we talked about before, what's the area of these triangles? What's just the half base times height, and then times it by the length. So this one would be a half times the base of 8 times 3 for the height, and then times 9 for the length. Simple. Half times base, which is 4, times 1 for the height, times 5. My handwriting will get better, I promise. Yeah, this one is actually quite interesting, this shape. So that's your parallelogram, if you can say it. But whenever you get a parallelogram or a rhombus, you're looking at a square or a rectangle, okay, which has been pushed. And we push it, it ends up being this kind of shape. Okay, that's what we're looking at. So to work out that area, if we were doing a rectangle, we would do the height times the base. Okay, we did the height of the base for that rectangle. We've just times this base length by the height, and that gives us that area in there. Okay, now if we do the same for a parallelogram, so if we've got this kind of shape over here, if we do the height of it times the base, we get the same area. Okay, which makes sense because it started life off as a rectangle. Okay, but the height we're using is this height here. Okay, and the length we're using is this one along here. Okay, we're not using the inclined length, we don't use that. Okay, so if we use the height and the base, if you think what we've done there, we actually worked out this area in here. If we do the base times the height, that's that area. Yeah. So what we've done is we've kind of missed out this area in here, but we've over-egged this area here. And actually these two areas are the same. Okay. So by not counting this area over here, we've taken account of that by adding it in over there. So that's why you do the height times the length. Okay. You don't do the inclined height of it. Okay, it's always the perpendicular heights. Same with triangles as well. Okay, if you've got a triangle, you would never use this length times this length, would you? You'd always use the perpendicular ones. So that'd be your height, and that'd be your base. Okay, and that makes sense again. So if you do height times base, you would actually work out the area of a rectangle. You'd be doing height times base, so it would give you this area in here. And if you do half of that, well, that's the triangle, isn't it? Height times base would give you the rectangle. If you do half of that, you would get that area in there. A half times base times height for your triangles. Okay, so dead straightforward for those kind of shapes. Okay, how are we doing for time? 7, just a quick one. Cylinders, again, just talked about that. Pi r squared h. The last one seemed to be wrong in the answers. It should be 9.82. Don't forget again, still centimeters cubed. The only thing I'd like to add to this would just be when you're using pi 3.14, they do that in the non-calculator paper to multiply decimals. So it's just a quick reminder of multiplying decimals, okay? So say 2.5 squared over there, okay? What's it roughly going to come out as, right? Well, 2 times 2 is 4, and 3 times 3 is 9. So it's between 4 and 9, okay, is roughly what you're going to get. So always think about decimals, like roughly what's it going to be, okay? So if you end up with 25 or 0.25, you've made a mistake, okay? So 2.5 times 2.5. Just ignore the decimal and just say, well, 25 times 25. What does that give me? I'll do 2 different colours. So 5 times 5 is 25. And 5 times 2 is 10. Plus the 2 is 12. Nice one. That makes sense, doesn't it? Because 5 25s, yeah, or 125. Okay, I'm happy. The next one, add your 0 in. Because we're going to do 2 times 5, which is 10. Okay, put the 1 up there. What I've actually done, though, we're actually saying 20 times 5, and that's why I put the 0 in there. Okay, so always remember your 0 on the second line. So 2 times 5 is 10. 2 times 2 is 4, plus the 1 is 5. Okay, and what I'm actually saying there is 5 times 25 is 125, and 20 times 25 is 500. Does that make sense? Does 20 times 25 give you 500? Well, 20 times 25 is the same as saying 2 times 10 times 25, isn't it? Well, 2 times 10 times 25, that's 250, and 2 250s are 500. So that's all fine. And then if we add it up, different colour again, that's going to give me 5, 2, and 6. Now this is the colour part. I ignored the decimal points at the beginning. I should have been doing 2.5 and 2.5, so I've ignored 2 decimal points, 1 in the first one, 1 in the second one. So now I'm going to add in 2 decimal points, 6.25. Okay, that's the thing I'd like to just highlight about this, because this bit's very straightforward, really. But sometimes people forget to multiply decimals. Okay, and that can come up in the non-calculator paper. Okay, nice.